So we're still in 6.3. And you have the instructions for finding the inverses in your notes. So find the inverse of y equals log base 6 of x minus 3. All right, so first rule, switch x and y. All right, so x equals log base 6 of y minus 3. All right, second rule, make sure your log is by itself. And it is. That y minus 3 is inside it, so it is by itself. So third rule, switch forms. Okay, so it's in log form. We're going to switch it to exponential form. The base is 6. The exponent is x. So you're going to go 6 to the x equals y minus 3. Final thing, solve for y. So you need to add 3. So you're going to have 6 to the x plus 3 equals y. Then write it as an inverse. Y inverse equals 6 to the x, then plus 3. Again, I'm going very quickly so you don't have a very long video to watch. However, you might need to pause it and take a look at that and take a little while longer. Okay, now I'm going to give you an exponential. Y equals 3 times 2/3 to the x plus 1. This is an exponential decay because 2/3 is less than 1. Now, first thing, let's switch x and y. So x equals 3 times 2/3 to the y minus 1, plus 1, sorry. Then I need to get my b to the y by itself. So the only thing I need to get rid of is that 3. I'm going to divide by 3. So now I have x over 3 equals 2/3 to the y plus 1. This is an exponential form. Now I need to switch forms. Here's my base 2/3. Here's my power x over 3. So I'm going to write this as log base 2/3 of x over 3 equals y plus 1. And finally, I need to solve for y. I'm going to subtract 1 on both sides. When I do that, I have log base 2/3 of x over 3 minus 1 equals y. And you can just go ahead and say y inverse. Okay, last but not least, I'm going to review some graphing. I'm going to do 2 graphs. We just did this in class on block day, and I noticed we needed some help. So here we go. Graph. Remember, our logarithmic functions are y equals a times the log base b of x minus h and thus plus k. So your a is your vertical stretch or shrink, or a reflection over the x-axis. X minus h moves us right or left, and plus k moves us up or down. Okay, so let's try. We are on number 15. Let's graph y equals 3 times the log base 4 of x and then minus 5. The first thing I instruct you to do in all of these is identify the parent graph. The parent graph would be y equals log base 4 of x. So we have our a value of 3 and we have our k value of negative 5. So telling what has happened there, the 3, that's your a, is a vertical stretch by 3. K is negative 5, so I'm moving down 5. Remember that every logarithmic graph has a vertical asymptote at x equals h. And in this case, h is 0 because I have not moved right or left. So my vertical asymptote is at x equals 0. Now I am going to just do a rough sketch of this graph when I draw it, okay? So no biggie here. This is beautiful. Okay, so here's my vertical, oops, I wanted red. Here's my vertical asymptote at x equals 0, right? Now, when we pick points to plug in, we always start 1 unit to the right of our asymptote. Because our asymptote is at 0, I'm going to plug in 1. And I'm actually going to move this so I have more space. Over here. If I plug in 1, that's 3 times the log base 4, 1, and then minus 5. The minus 5 happens after you do the log, okay? So you always do the log first. Hey, the log of any base of 1 is 0. So this is 3 times 0 minus 5. That's 0 minus 5. That's negative 5. I put in 1, I got out negative 5. So 1, negative 5. Let's say that's right there. Okay, then how I choose my next x value is I look at my base of my function. It is 4. What is the first power of 4? 4. And so I say, what would I put in for x to make that 4? That would obviously be 4. So when I plug 4 in, I'm going to have 3 times log base 4 of 4 minus 5. Log base 4 of 4 is 1. 3 times 1 minus 5 equals, that's 3 minus 5, negative 2. 4, negative 2. So 1, 2, 3, 4, negative 2. And your graph is growth like that. Here, I'll do it in blue so you can see it beautifully. Okay. And I will talk about domain range and end behavior more in class. I'm just more concerned about us being able to graph. All right, last one, everyone. Stick with me. We're rocking it. Here we go. Y equals log base 2 of x plus 4. All right, my parent function is y equals log base 2 of x. So the only thing I'm doing here is this plus 4, which is actually my h value, is negative 4. So I'm moving left 4, which changes my vertical asymptote to x equals negative 4. Right there. Okay, making a table of values, I'm going to pick my first x value is going to be the point directly to the right of my asymptote, so that would be negative 3. If I plug negative 3 into my function, that gives me the log base 2 of negative 3 plus 4. Well, negative 3 plus 4 is 1. And remember, log base 2 of 1, or the log of any base of 1 is 0. So I put in negative 3, got out 0. Boom. There it is. For my next point, I look at my base. My base is 2. So my first power of 2 is 2. So I ask myself, what would I put in for x to make that in parentheses 2? That would be negative 2. Because negative 2 plus 4. Ready for this? Is 2. And log base 2 of 2 is 1. So that was a nice one. I put in negative 2. I got out 1. Boom. And now I can draw my graph and be on my way. All right, guys. I hope that helped a little bit. We're going to be practicing more in class on Friday, and I'll see you then.